Hello and welcome to this stop motion video on evolution. So I'm not going to really cover everything on this topic because there's a ton of things, but we'll go through a few of the big things. So we're going to go through how evolution occurs, some natural selection mutations, some evidence for evolution, and genetic drift, which is another way that evolution can occur. So starting off, organisms evolve via mutations in natural selection. So here we got this population, got these yellow guys, and they don't blend very well. So the blue guy comes and eats all them. But a random mutation of SMAC cell changes the genotype and phenotype in offspring. And I want to make clear it's random. Organisms can't choose when to mutate. So here we got our new guy. This trait can be advantageous. As shown here, he now blends into the environment and he doesn't get eaten. So then he is more fit and he'll be more likely to pass this mutation on to his offspring. The other individuals are less fit and will be less likely to survive and pass their trait on. And this is called natural selection. This continues until every individual has the advantageous trait and the species has evolved. So homologous structure is an anatomical commodity in seemingly unrelated animals that shows a common ancestor. So here we got the arm of a common ancestor. It moves these different environments. So it goes to the cave, turns into a bat wing, moves to like the grasslands, turns into a horse leg, moves to the jungle, and turns into a jaguar arm or leg, moves to the water, and turns into a whale fin. So this is evidence for evolution. When the common ancestors moved to different environments, it had to adapt. And this is why seemingly unrelated animals have the same bones. Another piece of evidence are vestigial structures. So here we got our lizard ancestor, and it evolves into this snake thing. So the evolved snake has left or partial limbs. And these are called vestigial structures. There's no reason this snake would have these useless partial limbs unless an ancestor had a use for them. So another piece of evidence is the fossil record. So over time, fossils are stacked, allowing us to see how the bones changed. So here we got this first generation, and that gets covered up. The second generation is stacked on top of it. So then we dig this up later on. We can see how the organisms evolved, this timeline of bones. So the last piece of evidence is direct observation. After years of using antibiotics, bacteria become immune and create superbugs. Here's the old one. There's a new superbug, and it doesn't die with the antibiotics. These are just a few examples of evolution. There are several more, too many to count, and definitely too many to put in this stop motion. So genetic drift are chance effects that cause allele frequencies to fluctuate unpredictably from one generation to the next. And then a gene pool is a collection of alleles in a population. In order to understand these two segments we're covering next, we need to know that. So keep gene pool in mind. So the founder effect are few individuals that are separated from larger population. The smaller group may establish a new population whose gene pool differs from the originals. So here we got this species, and the species gets separated. So then the one on the right turns all green, while the one on the left stays relatively the same. But then the one on the right has evolved. And over time, they might become different species. So the bottleneck effect is a severe drop in population that results in certain alleles being overrepresented among the survivors, some unrepresented, and some absent altogether. So here we got these flowers, and this lava or fire comes through, and it ends up wiping out all of the pink flowers, most of the whites, and none of the purple flowers. So then later on, there will be no pink flowers. There's going to be a lot of purple flowers and just a few white flowers. Thank you for watching my stop motion video.